Hi everyone, welcome back to my videos. I'd like to do a tutorial on a single challenging problem related to circumference and arc length. So let's take a look at what it is. So we're given a radius of the large circle is 10. The radius of the small circle is equal to 2. The distance between the two centers, circle centers, is 16. We're given that triangle EAR is congruent to triangle ECR, and that the length of segment AB is equal to length of segment CD. So we're going to find the perimeter of the figure formed by arc AMC, segment AB, and segment CD, and arc BND. So the real world application of this would be like if you have a bicycle, right? And you have a chain, right, that wraps around part of a large circle and part of a small circle, and then there's kind of like a straight chain between these two sprockets. So that's probably the best real life equivalent of what this problem is. So, and we're going to find, basically we're trying to find the length of the chain we need to wrap it around these two circles correctly. So I've condensed some steps here, and even still it's a pretty long problem, so I might be a little bit fast with like the proofs and all that. So let's just get started with it. We write down what we know, and we know that segment RA is perpendicular to segment AB, and segment SB is perpendicular to segment AB. Why? Because our segment RA and segment SB are radii, right? And we know that radii are perpendicular to tangent segments, right? And I didn't write it down, but this, if we look at EA segment is going to be a tangent segment. So these two segments are going to be perpendicular at the point of tangency, right? And segment SB and segment EB are also going to be perpendicular because segment EB is a tangent and segment SB is a radius, right? So we know that angle RAE, this angle here, is going to be a right angle, and angle SBE is also a right angle. And we know all right angles are congruent. So in other words, angle RAE is going to be congruent to angle SBE. We also know that angle 1, so angle 1 is this little angle up here, is congruent to itself. So by the angle and angle theorem, using 7 and 8, we get triangle EAR is similar to triangle EBS. So we know in similar triangles, measures of corresponding sides are proportional. So in other words, SB divided by RA is going to be equal to ES divided by ER. We know that ER is equal to ES plus SR, right, by the betweenness property of segments. Well, we know that SR is going to be equal to RS, which is 16, right? So if we plug in what we have using the fact that RA equals 10 and SB equals 2, so if we just plug this in, we get 2 over 10 equals ES divided by ES plus 16. If we solve this, we get ES is equal to 4, and if we plug that back into 11, we get ER is equal to 20. So we found these lengths. So now we can apply the Pythagorean theorem to triangle EAR. So we know that RA squared plus AE squared is going to be equal to ER squared, right? So we can solve for AE. AE is equal to square root of ER squared minus RA squared. And we plug in the values. We know that ER is equal to 20, right? And we know that RA is equal to AR, right? And this is going to be 10, right? Because it's the radii, right, of the larger circle, radius of the large circle. So we end up with 10 times square root of 3. We can use the fact that in similar triangles, measures of corresponding sides are proportional. We get EB divided by EA is equal to ES divided by ER. And then we can solve for EB is equal to 2 times square root of 3. So we know that EA equals EB plus BA, right, by the betweenest properties of segments. So BA, the length of this segment here, is going to be 8 times the square root of 3. So we already know, since BA is equal to 8 times square root of 3, since we know that these two triangles are congruent, then CD is going to also be 8 times the square root of 3. So if we look at these triangles, we know that AR is equal to 10, right? And we know that ER is going to be 20, and we know that EA is going to be 10 times root 3. So if we look at these ratios, we have 10 root 3, 20, right? So if you divide each side by 10, you get 1 square root of 3, 2. Well, what is that? That's the ratio of the 30, 60, 90 degree triangle, since this is a right triangle. So we know that angle ARE, the measure of this, is going to be 60 degrees. We know that triangle EAR and triangle ECR are congruent. So we know that angle ARE is going to be congruent to angle CRE because corresponding parts of congruent triangles are congruent. And if we use the definition of congruence and substitution, we get measure of angle CRE is going to be 60 degrees. So if I add these two angles together by the angle addition postulate, I get 60 degrees plus 60 degrees. So angle ARC is going to be 120 degrees. We know that angle ARC is a central angle. Why? Because its vertex is at the center, right? And its sides are radii. So what that means is that this arc here, the minor arc, AC, is going to measure 120 degrees. So the measure of this arc, AMC, is going to be 360 minus 120, which is equal to 240. So 240 degrees for the arc AMC. We know the length of arc AMC is going to be equal to 240 divided by 360 times 2 times pi times the radius, which is 10. And if we simplify, we get 40 pi divided by 3. So that's going to be the length of this part of the figure, right? Now let's look at this part over here. So we know that angle BSE is going to be 60 degrees, right? Because triangle EBS is similar to triangle EAR, right? And in similar triangles, angles are congruent, so you can use, the definition of angle congruence, and then, you can reason it out. So we get angle BSE is equal to 60 degrees. So measure of angle BSD, this whole angle is going to be 120 degrees. So it's the same reasoning as we did in, part in 24. So just follow the same, steps of reasoning, how we showed that angle ARC was 120 degrees. I don't have any space to write this out, so a lot of this is already condensed. So anyway, the measure of this angle is going to be 120 degrees. So we know that angle BSD is a vertical angle, or not a vertical, a central angle, right? Because its vertex is at the center, right? And its sides are radii. So we know the measure of arc BND is going to also be equal to 120 degrees. So the length of arc BND is equal to 120 divided by 360 times 2 times pi times the radius of the smaller circle, which is 2. And if we simplify this out, we get 4 pi over 3. So we know the length of this portion of the figure is going to be 4 pi over 3. So we want the total perimeter of this kind of shape here. So we know that AB equals CD equals 8 times square root of 3. So we're going to have, we have to do twice of that, right, to get both these lengths here. So we get 16 times square root of 3 plus 40 times pi divided by 3 plus 4 times pi divided by 3. So this is going to be 44 pi over 3. So the total perimeter is 16 times square root of 3 plus 44 times pi divided by 3 by the perimeter formula. So this would give you, in theory, you know, the measure of this, you know, chain or rope that's kind of tied around these two circles that are kind of at a certain distance from each other. So I thought this was a really cool problem. It was very it was challenging, and you know, you should definitely go over it and look over the steps. And that's all I have for you. This is a short video, so I wish you guys good night, and I hope to see you during my next tutorials. All right, take care.